in the, you're going to have just about 5-6 minutes to state that. It's going to be a boxed item here, so you just have to state what's in this box. If I add additional explanation, it goes to the other side, right? So here's the beginning of a box, I think like this, and to the left you're going to draw this XY coordinate plane and draw this perfect circle. You just have to do your best to draw this perfect circle. Alright? And in your mind, you think it's a perfect circle. And you let the audience know that this is actually supposed to be a perfect circle. You know how to do that? So write down some equation. That's the beauty of it. Here's a picture. You write down equation. You communicate. This is supposed to be a perfect circle. What is that equation? Cartesian equation for the circle. X squared plus y squared equals r squared. 1 would be the unit circle, and here is any size circle that is centered at the origin. And you just put here is r comma 0 and there is 0 comma r additionally, right? That's part of your, everything has to be stated. If you're missing this equation, you will have 1 point off and things like that. Make sense? Alright, so it has to be stated that. And most important thing is that you gotta indicate that angle the way we understood. So I'm going to use different color. You don't have to in the test. So to indicate the generality, I'm just going to put this arbitrary angle side in the second quadrant. It could be third quadrant, it could be fourth quadrant, right? Any angle. Now, what is the last piece of information in the angle? Rotation, right? Isn't that right? Initial side here, and that's the terminal side, and rotation. What kind of rotation? Clockwise rotation and counterclockwise rotation. Anything in here, right? So, in general, I'm going to do something like that, indicating 2015 rotation. Then you end up in here. Something like that. Is that right? Okay. No problem. This is how we understand angles. The additional thing here is an additional circle isn't in here, right? So that's the terminal side. Good? If I call that point the terminal point on the circle, would that make sense? Terminal point on that circle, of that angle that you're indicating here. So next thing is that you have to kind of label that angle, theta, like that. That's my angle. I label it theta, right? Good? Next thing you have to label is that terminal point. XY coordinate, circle equation, angle indication, then you have to label that terminal point. That has x coordinate x, y coordinate y. Is that right? Okay. That's all the setup is necessary. So first, xy coordinate plane, draw a circle and equation of the circle, right? And draw the angle, all the rotation mark and theta, and terminal points. Alright. And this is a setup, and there's an angle, right? And we want to define angle of sine theta. We already have defined the sine theta, right? For what kind of angle? Between 0 and 90 degrees, right? Right triangle. Now, if theta is not 0 and 90 degrees, some crazy angle like that, we are about to kind of extend that definition in here. So what is the sine theta in here? Sine gets y coordinate. And you will see this connection all the way to the highest level of mathematics. Your instructor will assume that you know this, they call it a parameterization. How is x and y coordinate parameterized trigonometrically? And then you say, y is a sine coordinate, x is a cosine is x coordinate. That is something that you have to take that until you die. You have to remember if you're learning in mathematics. Denominator is the radius. Okay? And cosine theta, what did I just say about cosine? Cosine is related to x coordinate. So x coordinate gets there. Denominator is still radius of that circle. Instead of right triangle, what are we looking at here? Circle of radius r. That's the difference. What is it? The other one? tangent theta there, right? What is it? It's a y divided by x. Okay? Then you can imagine cosecant, secant, and cotangent. Just flip of these things, right? That's what that is. But I'm going to require only up to here for that quiz on Tuesday. If you state just this thing, there's no words in it, just this picture, nothing is missing, you get full credit for that. Make sense? This is called the definition of trigonometric functions of all angles. So notice here that this terminal point can be anywhere in this quadrant, right? But regardless of the location of the terminal point, the radius of the circle is always positive, right? How about y? That can be negative when you're down here in the third quadrant, when you're over here in the fourth quadrant, right? How about x here? That coordinate itself is going there. So when you're over in the second quadrant, when you're over there in the third quadrant, this can be a negative, right? How about here, x and y? Both are involved. If you're here, x and y both positive, right? Positive. If you're down here in third quadrant, what is it? X and y both negative. So together, positive. And the other two remain negative. So as we extend that, the sine and cosine and tangent value go through positive and negative values, right? And this is used to describe so-called harmonic motion and, in general, any vibrating motion using this general definition. It appears in every corner of mathematics and physics. Okay? That's the definition. And this is what you have to no hypotenuse, no h, no so-called in here. This is the fundamental, the definition that you have to state here. Okay, that's it.